Okay, now we're at the last part of the day. Hopefully this will be fun. Let me invite all of our speakers. All right, there we are. So now, in order to, have a lively panel, controversy is I want to somehow maximize it. So pretend speakers, you've all had a couple glasses of wine. All right. Loosen up a bit. We want your honest answers. All right. So let me first talk about the educational aspect, and then we'll get to researchy type questions. So now I guess for KRR researchers, if you think of yourself as primarily a KRR person, or vice versa, primarily an ML person, or maybe this is like, asking people their pronouns, now maybe you're both. So, but still, what feels mysterious about the other side, kind of, about ML if you're a KRR person, or hard to penetrate, or otherwise it's something you think we should cover in the future? Or do you think others find difficult, or don't know as much as they should? Okay, so if you're KRR, what on the ML side, or vice versa? If you're ML, what on the KRR side? Anybody?
Well, since anyone is, I'll try, and I'll try both sides actually. I think I identify more with KR, but I've published in ML, and I think a few years ago ML didn't seem mysterious to me. One thing that was mysterious to me was overfitting. I didn't think anyone could explain overfitting, and now everything seems mysterious to me. Because large language models, I mean, nobody knows how they work, and they seem to work, and nobody knows how to make them factual, or and overfitting seems even more complicated, even more mysterious. So now ML seems very mysterious. But KR, one thing that is I will try the controversial stuff. I think KR things are really clear to me, and people are always striving to understand. But what's mysterious is how do you actually use these things? Like suppose you have a conversational agent. Suppose you have an ontology. How do you actually work? How do you actually take the ontology and make it work in a conversation? So this is making it work is always mysterious. So that's my 2 cents, Alex.
Anybody want to follow up on that? I sort of agree. There was a time in machine learning where, overfitting was very clearly defined, and we absolutely did things like cross validation always, and now we don't for some reason. And so there is a new kind of mystery around it with these massive models.
So if I can add like a little bit to this question, Alex. So for KRR, I do feel that the use cases, although I do agree that it's becoming mysterious how it works, we don't know, but neural community or ML community handle more real life use cases. While KRR, I still believe most of the benchmarks are a little bit toyish. So that's one of my issue. That's one of the reason why people are not able to apply KRR things to their real life problems. So
maybe I can add to that. I mean, I have the feeling that, machine learning these days, and certainly neural networks, is very, very empirical. And I guess empirical is a mystery for a lot of KR people. On the other hand, if you look at KR, then people bother about semantics. They bother about proving things, which, seems less the case with, a lot of the neural network approaches where it's really hands-on. Let's try an architecture. Let's try to do something. and see whether it works. I guess that's not the way the typical KR person works. I mean, I guess a good mixture has both of them, and I've been spending all my life. I started in machine learning in a logic group, and I said, well, you guys have to do machine learning. Now I think the rest of my career I'm going to spend talking to the machine learning people. Well, guys, you have to look into reasoning and logics, and also there is value there, but let's see.
All right. Kind of a variation of that question. In your own work, working at the intersection, what's kind of expert do you find hardest to find or connect to on the other side, so to speak? Like I know, for example, many people try to get into knowledge graphs and then find out it's thick with a lot of details and wish they could find a knowledge graph person. Any other examples?
So I feel like from a little bit of my experience, I feel that some people are not ready to listen about other community at all, right? So they do believe that like either neural or symbolic will provide the full solution. So that's for me very difficult to work with in some cases. Benjamin raised his hand, so.
Go ahead, Benjamin.
I think one of the aspects I find most difficult to connect to is the opacity at the research level of how people go about picking and curating the large data sets that are used to train the state-of-the-art LLMs and some of the other big models. I really don't have a good sense of, how the allocation of resources, what the costs of different kind of data are, and why they pick some things, why they didn't pick other things. And this is, I think, a difficulty for a lot of researchers in the field that people have raised, but there just seems to be this sort of deafening silence going on, and I don't really get that.
I guess that's related to the fact that these come from things like the Common Crawl and it was originally came from behind closed doors kind of in big internet companies. So so there's a proprietariness sort of and but also a sheer enormity that makes it so nobody really can fully characterize what's in that full data set. But any other comments on that?
Yeah, I think these days people just use like the pile or common crawl because it just takes so much work to do it yourself, and it's a lot of the times it's just not worth it. But maybe it should be. Maybe we should pay more attention to better curating these sources.
And yeah, it's quite a difference from the early days of ML, as Les was reminding us when we had the UCI repository, and you could actually just inspect every line of the data set for many of those data sets.
Or at least know you're running on the same stuff. I do think that there's this emergent property as the number of parameters has scaled up the last couple of orders of magnitude in the transformer-based LLMs that is pretty much of a mystery as to why did things improve so much in some regards and not nearly as much in other regards. And I think that's a mystery for the whole field. So I don't know if it's particularly because I come more from the KRR side, but that's something that I'd like to understand how people are trying to tackle, at least.
Soham, you have your hand.
Yeah, just to follow up to that, like it becomes like very hard to design benchmarks and like really understand what it tells us, because like if hard to know what the model has already seen before during this massive closed corpora that was seen, like say on some compositionality benchmark you see that it performs very well, but like you don't know if it's because it has seen that or it's really not able to do that kind of it is able to do that kind of reasoning. And then even if you change the symbol names and so on. Maybe it's just doing a shallow mapping between the vocabulary. So it just gets really hard to draw insights because it's just enormous closed corpora.
By the way, let me just for our audience, any of my questions, if you have a comment, please put it in the Q&A or a related question or your own question, unrelated. So, what now, part of what we'd like to do here, oh, go ahead, Abu.
I was going to add to the previous comment and mention that there is a lot of work like happening right now in mechanistic interpretability, which is to try to basically decipher what is the algorithm that these transformer-based models and other neural models are learning when they're trained on these data sets. But at the moment, they're pretty limited to fairly small model sizes. And I agree, like it's not clear to me whether that will lead to, learning more about what is happening with these much larger models at the scales where you do see these emergent phenomena.
Good. Yeah, so one thing we'd like to do here with this ongoing series and collected group that keeps growing is, of course, establish a community and to accelerate progress in this kind of investigation. So what community resource, and this could be actually even within just KRR or within ML, or a sort of a cross-cutting or bridging thing. What community resource do you wish someone else would build if you could fund them? And be as specific as possible.
Something like Hugging Faces for large language models, a big repository of data sets and models that you can easily download and test.
You mean like a Hugging Face for neurosymbolic models or something?
Yeah.
Yeah, that's interesting. Benjamin?
I had some kind of similar sorts of thoughts to what Fabrizio was just saying, namely, I mean, I was a grad student when the UC Irvine repository was done for ML, and that just revolutionized the field of ML in terms of productivity, as Les mentioned during his talk. So I think we, in particular in the neurosymbolic area, more generally the area of what I'll call hybrid learning and reasoning, not necessarily neural net. On the ML side, we need a collection of software and also sets that are either a test or demonstration that combine knowledge, data, and some task queries that researchers can, compare their results in terms of, but also be thinking in terms of defining what are appropriate such kinds of, let me call them test sets for short, to drive research forward. And so I think, as someone mentioned earlier, a lot of the benchmarks in KRR, and this came up during question after my talk, are not so large scale or realistically complex. And, so for example, for Les's hypothesis about, reasoning helps, you need to have something that's complex enough in the kind of reasoning that puts stuff together that it's something that a big single model isn't already kind of doing mostly. So, and, I'd love to see this for, a good subset of the different kinds of approaches that people are doing. I mean, not all research is ready to be around such a repo or resource, but I think we need to get to the point where more of the work in our community is in that regard.
Yeah, and then one thing that was mentioned was that in KRR, you're not really generally dealing with approximate reasoning. You're dealing with the reasoning where you're going to get the right answer. So you don't typically have things like a reasoning data set, to test, the number of times you get the answer right and so on. So, but, in this, or at least certain of these investigations, we're now starting to have these reasoning data sets. But, we saw, Abu mentioned some, we saw a sort of variation of that, you could say, in the compositional generalization sort of context. You could think of those as those, systematicity and so on as really examples of similar to getting the chain right, similar to these reasoning data sets. So there are some data sets, and what's missing, say, or is a question I was going to ask tomorrow also. Do we have enough kind of benchmarks already between these we even have out of distribution, generalization, under that heading anyway, data sets starting to emerge. What's missing still from these things is that, and if nothing, should we just make a neurosymbolic suite of data sets to compare systems on, or or we sort of fine on benchmarks?
Well, I don't know enough about this, but I wonder whether the various benchmarks being used, do they all test for the same phenomenon, or is there a who says somebody is deterministic reasoning essentially, others are probabilistic reasoning? Maybe someone should spend time on understanding the different senses in which people try to mix learning and reasoning and appropriate benchmarks for each.
I just want to make a remark about, kind of crisp versus soft-edged knowledge and reasoning. In practical engineering, there's always a rate of error or something kind of pretty correlated with it, rate of change involved in maintenance in systems. And there's now enough, there's a long enough history and large enough scale deployments of things, for example, like knowledge graphs and business rule systems, the prologue systems and so on, that you could look at how often axioms or rules or whatever facts were changed. And, talking about something like a log error rate, okay, maybe it's only, got a much less than 1%, but there's a big difference between, say, 0.5% and 0.005%. There's almost always error rates in real system specifications of knowledge, even if it's crisp and logical knowledge, and even if it's things like verification where people are trying as hard as they can afford to get things absolutely right and perfect, as we all know as programmers and computer scientists.
Yeah, that reminds me that there's a sort of opacity there, which is the errors in very large knowledge graphs. People do report them, or report that they exist, but
Well,
it doesn't. Sort of like the large language models, it's so big that we don't have a clear picture of it.
Well, we could get crawlers to go in and measure this or track this in GitHub repos, for example, where a lot of stuff is, or other version control. And a lot of this stuff is public. A lot of this stuff is open. So I think it could be done, but people really haven't focused on doing it.
Alex, there are some interesting questions also in the Q&A.
Okay, let me jump to those. Will the current fashion paradigm of LLMs lead to another AI winter? Or will NESI, neurosymbolic, unite the two camps, leading to more realistic expectations? Who predicts an AI winter due to LLMs?
I don't. I think things are a lot better. I mean, in the 90s, for example, I was there in the 90s. I was not there in the 70s. Things were not working really well. I mean, they worked in the lab, but they didn't work in practice. So I think things have changed a lot. I don't think there will be a winter. There may be some disappointment, I think.
So, kind of related.
Can I disagree? I think there will be a winter because you can never underestimate the tendency, ability, and shamelessness of people who hype a new development. And this has happened over and over and over again. And so Gartner has what they call the hype curve. So I think LLMs will be hyped. I think they'll be the trough of dashed expectations, and then longer term, will outrun what the short termers were projecting.
This is good. Now we're cooking.
Yeah, okay. I'm just in the interest of having some controversy. Okay, I agree. Maybe LLMs will be too disappointing and will have a backlash. But AI as a whole, I mean, I don't think there will be neurosymbolic people there to help. I guess.
I guess. Sorry.
Yeah, go ahead.
I was going to say, if I had to guess, I'm not sure if like AI win something on the same level as AI winter would happen, but maybe like a bubble might burst. But I think one of the biggest problems coming up is just the fact that we're running out of data to train these models with, or useful data, I should say. And so it's not clear whether they can continue getting better with scale.
Yeah, I just want to clarify. I really meant an LLM winter rather than an overall AI winter. Yeah.
Maybe there will be an AI fall, but not a winter. So, right. Okay. On LLM, so they clearly do perform some reasoning, and I think it's not hopefully or presumably no one here would disagree that of course it's better to have completely correct reasoning, reliable reasoning rather than sometimes correct reasoning. But let me challenge in particular the KRR people with this question. So it does some reasoning. So there's some challenges as far as semantic understanding and improper inferences, hallucinations, but can we leverage, what are some short-term and long-term ways to leverage those reasoning capabilities? Maybe not in isolation.
I guess one of the things that one might try is like map to these intermediate representations and then call KR systems or solvers. To me, that seems to be a way to go. I mean, if you look at some of the approaches in planning, also in this mass word problems and the like, I guess that could be one way to go to solve complex problems, really. I mean, in reasoning.
Okay. Anybody else?
I can try a wild guess, Alex, if you allow me.
Yeah.
One thing I've seen, I mean, they do some reasoning, they fail, they do hallucinate, but one thing it's hard to predict the future, but one thing I think they do very well is to decide, and you can ask them, given this problem, should I ask a symbolic module? They can do this. I mean, and they do it reasonably well. So I think one thing that might be a good idea, I've seen this done, and it's not my idea, is to use a LLM to reason about when to call a symbolic reasoner. And I think that's actually a sort of a level 1, level 2 thinking, that they're doing the level 1 quickly and dirty, but that's helpful. I've seen this, and I think it's convincing to some extent. So this would be a small guess here that this will work.
Yeah, we saw Abu showed their works, and we're doing some of that work as well on calling out APIs. Those could be calculators, it could be reasoners, it could be planners. There's a question in the chat about in the Q&A about planners, so that's one way to bring in planning. The other thoughts on that? So, here's one from the Q&A. So how do you see symbolic logic affecting the future of language models? Does the steady improvement of LLMs on sophisticated reasoning tasks as they shrink in size and training time suggest symbolists should turn to low-rank adaptation of LLMs as an alternative to traditional logic programming methods? Sort of two questions. The future of LLMs, how does it change with the addition of the symbolic?
There's one question that I had, maybe for care people, and one that I also struggled with when I was working on symbolic methods back in grad schools. These large language models, they aim to be generalists, so they aim to be able to understand anything that you give them as input, any semantics, very rich semantics, and I'm wondering, if we want to incorporate a symbolic method or symbolic approach, or maybe even build a competing neurosymbolic approach, perhaps, then we would need the symbolic component to also be similarly rich and wide coverage and generalist, right? But I don't know, it seems like this is something I struggled with in grad school, is finding a formal representation, like an ontology or semantics, a language to describe the semantics of language that that has as much coverage and generality as these language models aim to do.
Yeah, maybe this relates to my earlier question about what would be a resource you wish someone would build. Maybe it's something like a massive knowledge graph or massive comprehensive grammar of English, or a massive common sense knowledge graph or something. A la Psych, to bring that up. Maybe a learned version of Psych. Comments?
Benjamin, you raised your hand.
Go ahead, Benjamin. Oh, you're muted, Benjamin.
I was talking plenty earlier, so I'll try to keep it short, but there is what's called the linked open data cloud in semantic web and so on. So, I mean, there's like a whole lot of mass of ontologies and so on. And I haven't seen anyone really try to kind of rationalize or map well between the different linked data using LLM or LLM type techniques, transformer-based neural nets. I think it would take a fair amount of resources because there's really a lot of data there. But that might help make some progress in the direction you were asking about, Abu. Yeah.
Another question in the Q&A. I've often thought that one large challenge with neurosymbolic systems is the impedance mismatch in terms of knowledge representation between symbolic systems and neural systems. On one hand, you have things like semantic networks and structured ontologies. On the other, you have natural language and opaque vectors of weights. Does anyone agree this is a major challenge? And any ideas where to look for the answer?
Yeah,
Well,
I agree. It's a major challenge. Well, it's hard to know how to solve this. I think something like neural predicates as championed by Luke is one nice try,
I mean, Luke's recipe arguably eliminates the need to worry about that mismatch, because underneath, in that recipe, underneath the neural predicate can be anything. It could be 10 billion weights. You never have to understand them. So you simply have to interpret the output as a probability. So, but maybe a version of this question is, do we ever need to go into a level deeper and understand?
Yeah, I guess like one thing is, I mean, it's a pretty superficial kind of interface yet, right? I guess if you could make the overlap between the neural network and the logic larger so that you can, for instance, manipulate the embeddings inside the logic, which is like what NTP does. And I guess there's a lot of related concepts that we might invent, like the soft unification to kind of get the best of both worlds, and that's a program that I'm kind of trying to pursue. Really kind of enlarge the interface. I mean, neural predicates are one interface, but there's certainly other primitives, maybe some of which we don't know yet, that would allow you know, to make it more uniform and more unified. And that's probably the way to go as a community as well.
I'm scanning the questions. I have one. So I'm very curious about this. You're all worked on really foundational problems that are somehow at the root of this intersection. So, but what foundational result would you like someone to work out or prove, or do you wish that more people would work on? What foundational results do we need? Theoretical result, essentially. Or a way, a problem that has not really been formalized yet as a theoretical problem. Go ahead, Fabio.
Well, I'll try one. One thing that has, you know, I would like to see this addressed, but I don't know how to solve this. But I think there's a lot of work in KR to characterize the expressivity of languages. People are really careful about this. People really care about what you can do with a particular language. And we don't have anything like this except for a few results, very nice, very interesting results for graph neural networks. So it would be nice to have some way of bringing this technology from KR, this concern about doing things carefully, into the world of neural networks and transformers. Not the large ones, because the large ones are like they can do anything, but to characterize, you know, with this architecture, you can express these things. I think even building a theory to do this is really a challenge. So I would read a paper on this. So if the question is what would be interesting, I think this one would be.
Comments on that? Go ahead, Abu.
Yeah, so one, I guess, line of work that comes to mind is Will Merrill's work, where he's been trying to interpret transformers as circuits and do theoretical analysis on that. And I think there's a recent paper, maybe from last year, where he found that a transformer is equivalent in specificity to first order logic with majority quantifiers, I think was the headline. It was very interesting, but of course that doesn't say anything about learnability. Like whether you can express a function has nothing to do with whether you can learn it, as we've seen many times with transformers. So I think that's a different question that's also very interesting. But I also would like to see more work done on like whether there are some fundamental limitations that even like generalize to the largest models of like certain algorithms or classes of algorithms that can't be learned.
Something, it sounds like you're talking about something like the Chomsky hierarchy or something like that. Right, Fabio? Maybe the kind of thing Soham was talking about relates to that. You know, characterizing essentially like what kinds of grammars you can learn effectively. And are you any comment, Soham?
Yeah, I just want to like say like what Fabio said in the second part, like, you know, that we should start with smaller architectures, and there's been some work that's shown like, like relatively small transformers, what kind of like regular languages they can learn, and like, which things. So that, yeah, so some special cases to show like something can be expressed or not. And it's like, because the things that are empirically successful is just very hard to know where to start to analyze those.
And Fabrizio, maybe this relates to, or a version of that could relate to sort of, the semantic richness of the underlying probabilistic representation, kind of, assuming there is a correspondence.
Yeah, of course. I mean, depending on the logic, you can have various levels of expressiveness, and especially with answer set programming, the the complexity changes a lot.
Luke, maybe in your work on ILP, thinking about the logical forms that are easier or harder to learn, maybe with different kinds of learning representations. Any thoughts maybe that emerged from there?
Yeah, I'm not sure about that. I mean, I guess maybe another thing is it might be interesting to get kind of some better notion of justification for some conclusions by these large language models. I mean, I guess that would be giving strong explanations, and yeah, I mean, like proofs. I mean, everybody talks about explanations, but it's kind of clear that they are probabilistic systems. They're extremely good at it. You get it for free. And it's so hard with these foundational models. And even if you get something, it's probably because you prompted it to do something. And I guess that would be also a major step ahead to get some more insight there, also into the reliability of conclusions, or yeah. But I didn't answer the question, but we'll put another one there. So sorry.
That's okay. You did better. It's just to move it to a different question that might be more answerable. Okay, so Les, of course, you would be the guy if someone's going to create a new theory for something. You would be the most likely candidate. Any thoughts on sort of really fundamental theoretical or phenomena that really don't have a good theoretical foundation yet, in your opinion?
Probably not a good answer, but to go back to the first topic about machine learning being a mystery, as my main response is that it's that machine learning algorithms have kind of, I haven't seen a big change because machine learning algorithms have always been a mystery. So even the simpler ones, decision trees, boosting, they all have some theorems about them, but it doesn't mean that we understood what the algorithm does in particular cases. Time ago, the mantra was, oh yes, we've got some algorithms, and we should really do research to find out when they work and when they don't work. So in some sense, this hasn't changed at all. So I think with deep learning, there are some theorems about them, but they're very far from explaining why the network would work in a particular. But it's always been like that, I think, for much simpler algorithms. Question of what to expect from theory, machine learning, I think, is a deep question. And I think theory, has been very helpful and is useful and amazing. But it's what it discusses isn't exactly what the practitioner wants to know. On this input, what will happen?
Yeah, maybe
Yeah.
Yeah. Go
Sorry.
ahead. No, go ahead.
Yeah, so there's some current works, in fact, deep learning and can be viewed as not general learning, but even this statistical query learning, which is a subclass of learning, and it's the known lower bound. So it's learning parities. So there's a hidden, because n Boolean variable subset of it, and you say yes or no depending on whether an even or odd number of that subset is true or not. So so provably for these SQ algorithms, it takes exponential in the size of this parity, whatever you do, and then so some limitations of deep learning reachable. The question we were asking is there anything about deep learning and reasoning which we can say something about, which is illuminating? Yeah, I think that's a good question, because we do have some techniques of approaching it. So yeah, try to identify some limitations in the reasoning direction of deep learning. Yeah. So someone should do that. Yes.
So one candidate maybe related to that, it strikes me, is this idea of learning to reason. So we've got a sort of activity now of trying to create a reasoner by giving it pairs of things where A entails B. So we give it a whole bunch of those, and learning theory would say eventually, asymptotically, you're going to be able to reason. So, but is there something more we could say in this idea of learning specifically to create a reasoner? Because this is a funny thing in some ways. This is, first of all, combinatorial. But and maybe it also gets more interesting when we demand that there be a correct explanation.
Again, so in general, just going back, I so in this community, I think we are talking about different kinds of reasoning. So some people are talking about reasoning from learned information, and some people are talking about reasoning where the information is learned at all. And different phenomena. So okay. So as far as what I'd like most from this community is someone to classify the different try to classify the different phenomena which we can. I think the community is looking at more than one. So so when I talked about one phenomenon, I think other speakers are talking about some other phenomenon. There's some some comparative study of the different phenomena which people think are worth studying within this community. Would be interesting. And I really don't know what the answer will be there.
Good. Any comments on that? Yes, this idea of learning kind of little nuggets that you're going to feed, and they're all noisy, and you're going to feed them into a reasoner, learned knowledge. I think it needs a lot more kind of a working out. Any thoughts?
Okay. I have one thought about that, Alex, which is, I think because a lot of the systems that are doing ML or that are doing reasoning work with fairly low expressiveness, they haven't really grappled with the following aspect. I think one way humans deal with a lot of noise in their knowledge is there's also a lot of redundancy in terms of the grain size, or kind of, we might have a conclusion of the form if A and B and D, then G and probably F, or something like that. And then we might have, individual smaller chunks of knowledge, like, A implies H and H implies uh, uh, either G or not E, or, stuff like that. And then we kind of use some of our knowledge to correct other of our knowledge, or at least to focus the questions to investigate or to think about cognitively. And we just don't see that aspect reflected in the algorithms and the systems that combine reasoning with learning yet very much.
Is it fair to say that we haven't gotten to those kind of more expressive logics because we're still grappling with more basic things at a propositional level?
Well, I think I think that's a lot of people have had the attitude, boy, we have a tough enough time dealing with knowledge whose form is not very complex. But one of the things I've learned kind of the hard way over the decades is that it's often a win to have a language that's more expressive because it's cheaper, more direct, quicker, more accurate and less error prone, more vettable, more trustworthy to have the more complex form. And it's a bit like, how in programming people have learned that, oh yeah, it's worth having 5th generation languages, not just programming in, say, a 2nd or 3rd generation one.
Okay.
So it's often a win.
Yeah, so this is a counterintuitive proposal, but it's, if I can paraphrase, maybe trying to do something a little bit harder. Like, let me throw out an example. Try to find a neural net, because in one of the questions was a response to you, Benjamin, saying neural nets are basically propositional, and sort of wondering about that. So what would be, say, a neural net with quantifiers, say, as an example of trying to go further in expressiveness and possibly breaking through some barrier as a result? Because for all, for example, is about an infinite number of things. So that would be a very different kind of representation, much more powerful kind of representation. Maybe that's an example.
Yeah, there has been a bit of work by Luciano Serafini and some collaborators, for example, on treating the quantifiers with t-norms. And there's some interesting issues, like if you're going for the Lukashevitz norm because it's relatively conservative epistemically, you're probably going to end up with 0 for your truth values for your bottom end of your interval for a lot of truth value intervals with numeric uncertainty. And so then they had some techniques to try to deal with that. And I mean, I thought they did good exploratory work on that, but I don't think it's really ready for prime time yet. And that's an example of some of the issues that come up when you try to raise the expressiveness some. Because the t-norm based stuff is a huge win in terms of computational complexity, but then it has these semantic challenges.
So Alex, there is this one last question. It's the last question in Q&A box, and can you please take care of that?
Then in the January workshop, there was the AMI system introduced, translates models into rule sets. Provided you had the full model of, say, GPT-4, could you make it explainable? We should probably get the speaker there to answer that. But that would be I would like to know the answer too. Related to this expressiveness, of course, one thing we learned today is there's a trade-off, of course, between expressiveness and computational cost. So, but even at the more basic logics, say propositional, we have an inherent kind of combinatorial aspect. So but one thing we saw, of course, that led to the dominance of neural nets is breakthrough in how to compute them way faster, which was heavily aided by hardware parallelism. Now, this seems, more difficult in this space because it's inherently somehow about sequences. But any comments, and somehow we need to go way faster, or at least the whole area of anything touching reasoning would benefit massively from being able to do that. Any thoughts? How do we break through that barrier and go way faster, orders of magnitude faster?
Well, there have been massive implementation efforts by big companies in neural networks and leading to like lots of great stuff that people can use just on the fly. I guess an effort like that is probably missing for most of the reasoning approaches, and that could also have a radical impact. I mean, that would be a resource that everybody would profit from.
What about that? But that was hardware and using parallelism and GPUs. That's a trick we know how to do, at least in computer science, but that seems like a hard trick to apply to reasoning. So, or true or false? What could we do there?
I think there's huge opportunities to do massive parallelism in LP++ type reasoning. If you look at the constructive semantics and so on, it's like a fixed point type of constructive. There's tremendous opportunity for concurrency fundamentally, but although that's been exploited in big data world, it hasn't really reached into people revamping and re-implementing because of the relative complexity of the algorithms in the more expressive type of logical KRR. But I think there is a real opportunity to do it.
Okay, great. So last question, coming back to our overall topic today. We attempted at least something difficult, which we'll attempt every year, which is a crash course on, and of course we can't cover everything, but we sort of have to have some depth on some things. So one answer is to have it longer, or longer version, which we were almost going to do this time, but ran out of time to do a much longer version, a 2-week version. But what would even be the right thing? What is the next level of this education? Would there be value, for example, in an open source semester-long neurosymbolic AI course? Or even just for this length course, a mini textbook to go along with it, along with the slides. Great comments on anything, and this includes our full audience. What would you like to see as the next level of this education? What would help the field? What would help facilitate more research, more understanding in this area? Thoughts, questions? Yep, go ahead, Fabio.
So I think, any material will be welcome. Okay, so if there's a class, if there's a course, semester, but I think one problem with neurosymbolics that has become a sort of complex area with many different things. So if you organize a course, there's going to be the danger of too many things, too many small things touched. So I would think, for me, it would be very nice to have a textbook just explaining what the various things are. I'm not sure whether Leslie meant this, but I think just explaining what the various kinds of neurosymbolic reasoning there are would be useful. Okay.
I see at least one comment in the chat answering a deeper dive into commercial deployment. Information on the state of the industry. Okay, great. Well, we're coming up on an hour, so any last comment or question to pose to tomorrow's speakers or anything? Okay. Thanks so much to everyone, and really proud to have such a great collection of experts teach us new things today. So thanks everyone, and thanks for to our audience. It's very, very late for some people in the world. Okay, and we'll see you all tomorrow at 9 a.m.
Yes, tomorrow we start at 9 a.m. So see you there. So for all the speakers, if you can stay online for a few more minutes. So.
All right, thank you. Thanks a lot. Bye-bye.
Thank you.
Thank you.
Thank you.